All right, welcome back everybody to our 2025 AP Calculus AP AB free response questions, the FRQs for this test. Keep in mind we are now on number 3, which is the non-calculator section. You will have to do your calculations manually here. We have about an hour for 4 problems. So what that basically means was we need to be able to finish our problems in under 15 minutes. With that being said, let's jump right into it. I talked about before where most of these problems that we get are going to be one of 3 different categories, whether it's going to be a function, it's going to be a graph, or a data table. As you can see, this is one of the data tables. With that being said, we are very often going to be dealing with rate of change and also Riemann sums when it comes to these. Let's go ahead. A student starts reading a book at time t equals 0 minutes and continues reading for the next 10 minutes. The rate at which the student reads is modeled by the differentiable function r, where r of t is measured in words per minute. Selected values of RT are given in the table shown. Okay, so we're given words per minute from 0 to 10. All right, and given values for each of those. Approximate R prime of 1 using the average rate of change of R over the interval of 0 to 2. All right, because 1 exists in the middle right here, we can actually use our average rate of change. So R prime of 1 is equal to r of 2 minus r of 0 over 2 minus 0. In this situation, we also have words per minute over minutes. So that's words per minute per minute. Keep in mind that's what our indicate units of measure is going to be important here, making sure that's shown. So that gives us 100 minus 90 over 2 minus 0, which is 10 over 2, which is 5. 5 words per minute per minute. Okay, I'm using shorthand there. Make sure you write it all out for yourself. So that's going to be our answer. This is the first part of our equation. That being said, you can see here, let me erase a few of these things. To score this and to get this correctly, we need to make sure that we have our answer with the setup. Right there we go. We got that first point. All right. Second part is the units. Words per minute per minute. 5 words per minute per minute. Okay. So in order to get both points, we have to make sure that we show that entire thing. You can also get the points by saying words per minute squared. Okay. Um, Notice here that if you just have this part of the function, just the part on the right, it is not sufficient to get your answer, okay, to get your point. Um, and to earn the first point, showing that calculation is worthy. Okay, let's go back. B, there must be a value C for this between 0 and 10 that R of C is equal to 155. Justify your answer. Well, the first thing that we need to understand here is we need to identify that because this is a differentiable function r, it means that this entire function here is continuous, okay? So r of t is continuous and differentiable. As a result, between these values, we can see they're looking for 155. That happens to be in between our two values. So r of 0, which also happens to be 90, and we also have r of 10, which happens to be 162. Okay, so this is in between the two, the high and the low. Therefore, with our intermediate value theorem, that basically shows between those two values, then we have an r of c that must exist in between those. All right. Let's erase this for you guys so we can read it. Okay. R is differentiable implies R is continuous, right? Differentiable continuous and differentiable. Our answer with the justification with our intermediate value theorem, there must be a value C such that it is in between. There we go. Okay. So point 3 and 4 here, we got all of that by showing our equations and our justification. Back to the problem. Using the trapezoidal sum with the 3 subintervals indicated by the data, 1, 2, 3, to approximate the value of r of t, the integral of r of t from 0 to 10 dt, show the work that leads to your answer. We have to show our work here, guys, okay? So the integral of 0 to 10 of r of t dt, that equals, and we're using trapezoidal sum, so that basically means we need to take r of 0 plus r of 2, divide that by 2 for the trapezoid side, and we're going to multiply it by the distance between the two. So that's that first segment, right? You can also imagine if this was 0 to 8 and 10. We're going to show our markings here. We got 90 to 100. We got 100 to 150. And then 162. Okay, so we're adding these two numbers and we're dividing by 2 to find the trapezoid, and then we're multiplying by the base. Okay, so I need a little bit more room for this. Let's just write the rest of it. So the first part was r of 0 plus r of 2 over 2. Multiply that by the base. Okay, then we're going to add that to r of 2 plus r of 8 over 8 minus 2, or sorry, over 2. That's trapezoid times r 8 minus 2. And then r of 10 minus plus r of 8 plus r of 10, sorry, over that 2 and multiply that by 10 minus 2. Okay. Plug in those numbers, 90 plus 100 over 2 times 2, 100 plus 150 over 2 times 6, and 150 plus 162 over 2 times 10 minus 8 is 2. Okay, so that's our full function. Do your calculations there and you'll have your answer. And there we go. So first part of our function showing that this is equal to 1, 2, 3. 1, 2, 3. That's our trapezoidal sum. And then our answer with the supporting work. I know I didn't calculate the whole thing, but I did get us to this point. And solve. Okay. Oh, did I write the wrong 10? It was 10 minus 8 at the, oh no, that was from the above. This was, there we go. Cool. Last part of this equation. The teacher starts reading at time equals 0 minutes and continues reading for the next 10 minutes. The rate at which the teacher reads is modeled by the function W, defined by this function, where W of t is measured in words per minute. Based on the model, how many words has the teacher read by the end of the 10 minutes? Show the work that leads to your answer. Okay. This one's fairly straightforward. We're basically integrating this function from 0 to 10. So if I have my integral of the negative 3 over 10t squared plus 8t plus 100 dt, we're basically going backwards on that derivative, right? So this 3 pops up to the top of this. We have a negative 1 over 10 to the t to the third. This t becomes a squared, so that leaves a 4 up here, and then we have our 100t. We're evaluating it from 10 and then minus 0. So we're plugging in 10 for each of these t's, subtracting it where we would plug in 0 as well, and coming up with our algebraic solution. So as you can see here, our function, integral, evaluate, and then get our answer to evaluate there. Okay. Showing this as well based on model, the teacher has read 1,300 words by the end of the 10 minutes is also important to show, right? How many words? All right. We got that done right around 15 minutes, but obviously I have to switch back and forth to show you guys and evaluate those answers. Stick with us. We're going to go into number 4 in the next video, number 4, 5, and 6, to show you guys how to do those as well. See you in the next one.